Hello everyone. So this video is about Pert and CPM. So both of these are networking techniques. And what do you understand by networking techniques? It is flow of activities. Okay, so so let's learn about them in more detail. So Pert is basically project evaluation review technique, and we can call it as program evaluation review technique as well. And CPM is critical path. So you can see both these network diagrams. These are basically your network diagrams, right? These are known as network diagrams, these figures. So what is network? You can see it is basically a sequence of activities, right? So both these activities, basically you can see some time is given, right? And we can see there's a activity 30 that will start after completion of activity 20, and likewise. So in critical path method network diagram also you can see there's a start node. Okay, so it means that your project is starting, and then after starting your project you can start with different activities. So here you can see activity R will start when activity P is completed. In nodes, this P, R, U, S, all these are denoted by all these are denoting various activities. Okay, so we'll study about these in more detail. So project management is one part of operations management where you are dealing with a project. So what is the major difference between projects and operations management? Because operations are basically deal with kind of routine kind of activities which are repetitive in nature, and projects are mostly certain set of tasks that we need to accomplish, and there are certain timelines that we need to meet. Okay, so to meet those deadlines we need to plan our activities very wisely. So project management is basically managing a project, and by systematically planning it, scheduling it, executing it, monitoring and controlling it. So for all these functions, we need to have a network diagram first of all to see what will be the flow of activities and what would be what would be resource allocation and what is the status of our project. Okay, so both of these are two network based project management techniques. Okay, so critical path method is this I'll explain you in the next table. So critical path matters network analysis technique used in planning, scheduling, and controlling of complex but routine activities. So what is the basic difference between PERT and CPM? Let's come here directly. So PERT is basically a probabilistic approach where we deal with three time estimates. You will see, there's optimistic time, most likely time, and pessimistic time. So what does these three times estimate indicate? So suppose when you talk about COVID vaccination, like when this COVID came, so there were certain estimates that will get a vaccine in say most when we talk about optimistic scenario, we'll get our COVID vaccine in 2 months, say in coming 2 months, considering see all the things will go according to plan. We will get resources that at the at the time when we need them. Okay, and pessimistic approach can be like you can think of the worst case scenario, like what can go wrong that during vaccine development stage, so things can go haywire and how much time it will take. And most likely time is basically the estimate given by experts that for these kind of vaccine, like to if we are developing these kind of vaccine, what are various activities, and we can give proper time estimate that in this much time your vaccine will be ready. So as we can see, it is not certain because you are working on a new project, right? New vaccine development, or you are developing new missile and like that. Okay, so for certain these kind of activities where there's uncertainty involved, we use PERT, right? On the other hand, when we talk about critical path method, here activities are time taken to complete the activities is clearly known, right? Because mostly those are uh, you know reoccurring activities, or we have database related to time taken by these activities. So per techniques is best suited for high precision time estimate, and it deals with unpredictable activities like I told you earlier. Okay, so CPM mostly deals with predictable activities, And in PERT diagram, we are just calculating the time estimate, and there's no demarcation between critical and non-critical activities. And CPM, there's a demarcation between critical and non-critical activities. So what do you understand by critical and non-critical activities? I'll let you know in coming slides. So PERT is used where nature of job is non-repetitive, and CPM basically non-research projects like construction project, etc. So for R&D projects, definitely we'll be using PERT to find out the time estimates. And it is kind of probabilistic approach, and it is deterministic approach that we know that this much time would be taken. And the crashing concept is basically, how you can basically reduce the time of that project by employing more resources. Okay, so that concept is not applicable in PERT, but in CPM kind of activities we can compress the timing of our project by project crashing. So so let's study how we can calculate the time estimate using PER technique. Okay, so here for mostly you will have pessimistic 3 time estimate. As I told you, pessimistic is worst case scenario, time taken in worst case scenario. Most likely time taken by an activity in a kind of realistic scenario. And optimistic, सब कुछ हो जाएगा, है ना, time पे शुरू हो जाएगा. So in the best case scenario. Okay, so these are formulas that we use to calculate the time estimate for particular activity. Suppose I have given pessimistic time, most likely time, and optimistic time. These time estimates are taken from experts. Okay, so they can give you better idea what can be the pessimistic scenario and what can be the optimistic scenario. So these time are basically given by experts. Okay, so you can calculate mu, that is your mean time taken by the activity. And when we need to calculate a standard deviation, so as we have already studied in business stat, so standard deviation is basically the dispersion from the mean. Okay, so to calculate standard deviation we can use the formula p minus o divided by 6 for this particular for part calculations, and variance is definitely square of standard deviation. So suppose when we talk about normal distribution curve, right, we already know that 68% of the values are contained in one standard deviation away. And when we talk about two standard deviation, mostly 95.4% of the values are contained in that. And when we talk about three standard deviation, it would be 99.7% values will fall under that area. So let's consider this example where OPM are given. So using that particular formula, we can calculate the mean time, P plus 4 times M plus 1 O divided by 6. So here we are giving more weightage to most likely time. So here we are using multiplying it by 4. So we get 35. And when we calculate standard deviation for this particular activity, that would be 8. So when we see kitna deviation hoga when we talk about one standard deviation away, so it will be 35 minus 8 to 35 plus 8. So 68% of the time, your time will vary between these two values, 27 and 43, and likewise. Okay. So this is another example where your activities will be given, their mean time, 3 time estimate would be given. So you can calculate the expected value, you can calculate the standard deviation and variance for that particular activity. For example, 135, you'll apply this formula, 1 plus 4 times 3 plus 5 divided by 6. So you'll get value as 3, and standard deviation would be 5 minus A divided by your 6, right? So 5 minus 1 divided by 6. So it will be 2 by 3. Okay, so likewise you can calculate and you can explain your answer as well. Okay, so this is just an example of network diagram. So we all know now like how to calculate the expected value time. Now let's talk about network diagram. So what is network diagram? It is basically, you can say, flow, a diagram which shows the flow of activities. Like for example, after 1, your activity 2 will start, 3 will start, and 3 will start, and likewise. So there are 2 ways you can construct network diagram by using 2 method, activity on arc, where this is known as node and this is known as arc. So here in this particular example, you are mentioning activities on the arrow. So it is activity on arc. So sometimes you can just mention activities on this node, right? So in exam, you can do it activity on node, right? So it will be easier for you, and there will be no issues related to dummy activity that we are studying in the class. Okay, so you can just go through this slide. Okay, so let me explain you the concept using this particular case. So this is a case about impending move of credit card operation to Des Moines, Iowa from the home office in Dallas, and which is a project of Rebecca Goldstein and Global Oil. So now the board of directors Global has set a firm deadline of 22 weeks for the move to be accomplished, right? So there's a project about office movement and the deadline is of 22 weeks. And Becky is a manager in operations analysis group. She's in charge of planning the move, seeing everything. Basically, she's given the responsibility to make this transition or this project successful. Okay, so there are many things involved. First thing is that there are 3 available office sites. After those 3 sites, one site would be selected. Okay, and there are many departments are involved in this move. For example, personnel has to determine which employees from Dallas will move and how many new employees to hire, etc. And system group and treasurer office must organize and implement the operating procedure and financial arrangements for the new operation. So all different departments are involved, and architects will have to design the interiors once the site is approved, right? So second complicating factor is that there's interdependence of activity. For example, you can't hire people unless and until you know that what is the requirement. So activities will move in a particular sequence. Okay, so there's always interdependence of activities. In other words, some parts of the project cannot be started until other parts are completed. Okay, for example, Global cannot construct the interior before it has been designed, right? And neither it can hire new employees until it has determined the requirements. So Becky knows Pert and CPM are designed for such type of project. So she chose to take help of these networking techniques. Okay, so see, the most important part is to find out what is the relationship between interdependence between these activities. So the management or the project manager has to dedicate a lot of time to draw a proper relationship, right? To find out the proper relationship, so that there will be no omissions in the project or error ka chance kam se kam ho. Otherwise, it will lead to a wrong network diagram and wrong planning, obviously, right? So skipping a bit, you can go through it. So this is basically about the diagram, about the activities relationship interdependence. So immediate predecessor kya hoga here? Like suppose there are 2 activities, A and B. So B can only start after A will finish. So A will be the predecessor activity for activity B. Okay. And suppose there's activity C in a project which can only start after A and B are completed. So A and B here will be your predecessor activity for C. So suppose this is the table. So you can get questions both ways, like you can be given a table or you need to draw this table based on the what problem given. Okay, so here, there are different activities which are described, and they are denoted by A, B, C, D, E, F. And here in this particular column, immediate predecessors are given, right? So when you need to draw the network diagram, right, you can use both the methods. So for this particular exam, you can use activity on node, but in class we have done in much detail and both types of diagrams. Okay, so when you can use both way, you can use a start activity or you can directly start from it. Suppose here I have to go sequence wise. Suppose your activity, first activity is A, so I'll write activity A, right? Got it? So now you'll move to next activity in particular sequence. So next activity is B. Then you have to check for immediate predecessor. There's no predecessor. So activity B can start from here, right? And when you talk about next activity C, it will start after B. So C will start after B. So here activities are represented on node, right? So there will be no issue. And then we talk about D. See, D, when you check predecessor activities of D, they are both A and C. So what you can do, and you can draw a node, and in this node, you will draw like this. What does this indicate? D activity can start after A and C both are completed, right? So it shows a proper relationship. Then you have D. So after D, E will start. No, your diagram can be of any type, but it should be, it should clearly consider all the relationship. And then after C, you have F, right? And G will start after F. G ka predecessor is F, so after F we can start G. Excuse me for bad drawing. You have to draw it very neatly. Then after H, H will also starting after F, right? So suppose I'll draw H here. Then B, you have I, right? B के बाद आपका I start होगा. So you can see I here. And J, train new personnel, it start after E, H and G. So when all these three activities will finish, you know, it will, J will start, and this is the last activity. You can do one thing to make your, diagram more clear. You can write start node here. It can be a starting node, which will see after start, it is starting after ND, and you can have an end node to show the end of project where both ending activities, end node you can write, right? Finish or end node. So J and I you can enter here. So this is your network diagram. Okay. So in the class we learn the concept of dummy as well, right? So this is basically where you are representing your activity on arc rather than nodes, where node are numbered and you are representing it on uh, arc. Okay. So we are skipping that thing for your exam. So this is your activity on node for the given problem that we just drew, right? So this is how you draw the network diagram, right? So there are, as we are, for your exam, I told you to note, you can just go with network diagram. So there are two ways to calculate, critical path method. No, to understand what do we understand by critical path method, we need to identify what is the critical path. And what is critical path? Critical path consists of activities which are critical for the project. Now you'll be wondering, all activities should be completed, so why only those activities are called critical, right? So those activities are called critical because we don't have slack available for those activities. Suppose in this particular example, we knew that using this table where timing was also given, right? For activity A, it is 3. For activity B, it is 5. And for activity C, it is 3. Okay. And for activity D, it is A and C. Okay. So when we see in this diagram, right, A and B are starting activities, so they can start at 0, right? But C only start after B is finished, right? So B is taking 5 weeks to finish, so C can start after 5 weeks only. Okay, so there are certain activities which will only start when predecessor activities are completed. So C ka predecessor activities B, right? So it can only start after that. And similarly for D, it starts after B is after A and C. So A will finish after 3 weeks because A is only taking 3 weeks, and then C only starts after B. So C can start after 5 weeks, and again, when B is completed, and it is taking 3 weeks to complete itself. So when C will finish off it in 8 weeks. So D can only start when A and C both are finished. Okay, so and then D will start. But here you can say the case, for example, before activity D, B and C both should be complete and A should be complete. But C will complete at 8 weeks. So A can be started at a later time as well, so that project is not delayed, right? So A activity is definitely very important because only then only all other activities will start. But A has the slack available that it can start little late. It won't hamper the project, progress, right? So critical activities are those activities which are basically which they don't have any margin available to them, that if they are delayed it will impact complete project duration. कि अगर थोड़ा सा भी उन एक्टिविटीज में डिले होता है तो पूरा का पूरा प्रोजेक्ट का टाइम ड्यूरेशन बढ़ जाएगा, इसीलिए हम उनको क्रिटिकल एक्टिविटीज बोलते हैं। और बाकी जो एक्टिविटीज हैं डेफिनेटली वी नीड टू कंप्लीट, so we call them non critical activities. Okay, so this is how it is done. Okay, so as we did in the class, so the margin available is known as slack. So I'll show you one more method to find out, one way to calculate critical path method, right? So just a minute. Let me explain you using this diagram. So suppose this is a very simple network diagram, right? So first of all, we need to determine how many paths are being transversed in our network diagram. So what is a path? It is basically, sequence of activities from start node to end node. So here you see you can go from start to last activity. First path is this and second path is this one, right? So there are two paths. So what you have to do in a very simple way to calculate the critical path method, you need to find out the duration of the project. Okay, duration of different paths, which are being transferred. For example, 32 plus 40 would be 72 and 120 it would be 192, right? So this is your path 1 duration. Then you have path 2, it is 74 and 194. So the path which is taking more time, okay, the longest path becomes your critical path, the critical path for that particular project. Okay, so when we talk about critical path, so this path would be the critical path, that is the longer one, and also the activities that are falling on this path are known as critical activities that cannot be delayed, right? So this is how you do the calculation. Okay, so rest of the things we have covered in class also numerous times, right? So project trashing also we have discussed, so I'm skipping it here. Okay, so all the best for your exam. Okay, bye everyone.